Alrighty, hey everybody, and oh my god, I'm so happy to see everyone again. I'm Cheryl. This is Cloud Native London. I'm getting an echo. Yeah, does anyone else hear?
Yeah, let me figure out how to not do that. Maybe.
Hello. Still a bit of an echo.
Yeah. Try now.
Hello.
Hey, great.
Sweet. Amazing. So if you're joining online, amazing. If you're here in person, amazing as well. I'm going to do a quick introduction for Cloud Native London before we kick off tonight. So first off, if you're here in person, the Wi-Fi and password are on the bottom left. esynergy guest solution 1234.
Terrible password.
Not going to mention this, but welcome. We are a strong, open, diverse developer community dedicated to the cloud native platform and technologies in London, actually in London. So I'm Cheryl. I am on Twitter as Cheryl. I hang out around the cloud native community. Tonight we have 3 speakers. So first up we have Chris, who's going to talk about policy as versioned code. Then Rick, who's going to encourage us to throw away our passwords and trusting workload identity. And then we have Bruno. Bruno, he's going to talk about cloud native runtime security with Sysdig and Falco. And then we're going to wrap up at 9 o'clock. So first of all, thank you to tonight's sponsors. So Kevin, do you want to come up and introduce esynergy?
I'm trying not to walk that way. For those online, you can't see the cables, and I'm trying not to kick everything off the stand. Can I just extend my welcome? We're absolutely thrilled to be sponsoring this event. Welcome to our offices. esynergy are a tech consultancy. We do a lot of work in the cloud space. Lots of building platforms, lots of DevOps, lots of application modernization and migration work. We're always open. We run an associate model, so we're always open to hear from people who are looking for work and like to be part of our community. And actually, you know, whether you're on a gig through us or not, you know, we welcome collaboration and communication. And so, yeah, you're welcome to take part in our communities and come along to events like this that we put on. We're very keen to engage with you and learn from you. And so it's a model of learning from each other and working new stuff out together and enjoying the cloud space and pushing the boundaries of that. So we're very welcome here. We're thrilled to be doing this in person, and I think we're going to be here every month actually. So hopefully that's in your sat nav now, and you know where to come. So good, welcome, and do let us know if you'd like to join the esynergy community.
Thank you, Kevin. And again, yeah, thank you for donating use of this office. Circle CI, I'm going to read out a little spiel for them because they couldn't come tonight. It said, the world's best software teams use Circle CI to deliver quality code with confidence. As the largest CI/CD platform, Circle CI empowers engineers to seamlessly take ideas to execution at scale. Every feature of our platform is built to fine-tune the entire development process from start to finish. Palo Alto Networks, I believe, also couldn't show unless someone... Oh,
that's because I didn't know you know I was coming. Sorry.
No, I was just like.
So yeah, hi everybody online and here. Yeah, Prisma Cloud, part of Palo Alto Networks. So essentially, we're the cloud native division of Palo Alto Networks, a security company. All of our focus is around securing your cloud native workloads as you move into public cloud, or perhaps you're running, you know, Kubernetes on premises as well. Hopefully we'll get a chance to speak to you perhaps later in the year as well and give you a bit more insight into what we're up to helping customers. But in essence, most of what we're focused around at the moment is securing your applications against critical vulnerabilities, and also looking at how things are configured, best practices around how images are configured, but also how your infrastructure as code template is deploying resources into public cloud, particularly regarding Terraform, but also things like Kubernetes app YAML files, for example, and how they're composed. So those 2 issues alone are probably the 98% of what the challenges we see in terms of the noise that happens happens in public cloud with regards to security. So addressing those within the life cycle is primarily our key focus, implementing visibility within IDEs or code repos directly, or of course CI tools is a big piece of what we do. So yeah, pleasure to sponsor it on behalf of Prisma Cloud, Palo Alto Networks, and yeah, I'll be around this evening if you want to speak to me more about Prisma Cloud. Thanks very much.
Thank
Take
you. Thank you. All right, Bruno. Say hello. You guys got to stay.
Yeah. Hello, everyone. Thank you first for being here. As in behalf of Sysdig, first I would really thank for you people in person and online, as without community, we don't have the cloud. It's very clear. This is a CNCF event. So if you were in the KubeCon, as I see a KubeCon t-shirt here, we know that's how this is important. Some people start from the beginning of the journey. Some people are more advanced. This is the community. We are here to exchange ideas, to give talks, and talk about a little bit about Sysdig. We also believe in community. We have some open source products. Basically, we have two products: Sysdig Secure for cloud unification, and Sysdig Monitor, which is like Kubernetes monitoring. But today, I really want to say thank you to be here, because without community, this not be possible. Thank you.
Thank you so much. Again, thank you to our sponsors, because they buy pizza, beer, and have kept this meetup going for the last 2 years that we've been online. Okay. Right, a little bit about you now. So if you have your phone, I want to check that this works first, because I checked this 15 minutes ago, it worked, and I checked it 1 minute ago, it wasn't working. So as luck would have it, we're just going to do hands instead of doing it on your phone. But so is this your first time at Cloud Native London? Oh, amazing. Like I don't know, quarter of people said that this is the first time when they've actually showed up to the in-person meetup. So I guess if this is not your first time, that's everybody else. So amazing to have you back. You should ask, where are you based? We're all in London, and the people remotely don't have a way to say where they are, so we're going to skip this question. And then just quick poll, like, what's your job title, roughly the closest one? So architects, 1, 2, application developers, 1, backend developer, 2 or 3, engineering manager. Say again, Michael, say again. No, Michael, say again.
I was joking. Anybody has a job.
Anybody has a job. Okay. SRE/DevOps engineer. Like most people, I think, half people. Security. 1, 2, 3. Yeah. And anything else? Anything else? Oh. Yeah, handful of people as well. All right. So, Chris, this was your question. So, why don't you read it out?
Yeah. What is your favorite policy? So by show of hands, you can have multiple choices here of a don't run as root, a group. Everyone loves a bit of AD. Come on.
Yeah.
Always paying half on a date. Honesty. That's a good policy. The best policy. You can't say that, Lewis. Any a promiscuous policy. He likes a promiscuous policy.
Oh, policy.
There you go. And beer before wine. It's also a good policy. Cool. Thanks.
Okay, now we have Rick. You wanna-
I've got a funny feeling I'm not taking this quite seriously as maybe I should have done. So what is Web Identity Federation? Is it a regulatory body overseeing social media handles? A professional wrestling promotion company? Or is it a way to exchange identity for temporary cloud credentials? It's that one.
I feel like there might be a few I don't knows.
That's good. So I learned some stuff I'll talk about. Hopefully,
Cool.
that's the plan.
All right, Bruno, you want to read your question?
Yeah. If you go, I'm just trying to turn the mic up a bit. So hopefully be better.
Okay. So how do you know what's happening inside your container at OS level? So who think logs can provide this? Oh, nice. Tracing, maybe, if you have some developers. Yeah, half hand. And then others, well, we're going to check later, but other, it's the response. Yeah, also I take this serious, so it's more question. Yeah, I didn't get the idea to be joking. So if I have vulnerability management, do you think do you really need runtime security, or vulnerability management is enough? Or do you think yes or no?
Yes. Yes.
The last one, sorry. How much do you have about Kubernetes API events? Like if a new object is created, airbag modification changes, how do you feel that you have inside your clusters? So none, like kind of blind spots. I trust my cloud provider. No, okay. And the correct one, let's say, like have live Kubernetes updates. So I hope you have this also in mind, because we're going to be interested for that talk later.
Great, thank you so much. Thank you for taking part as well in the polling. A quick selfie time, because this is, as the first in-person one, I have to do selfie. Okay, everyone's gonna, oh, there's a lot of light up there. That's okay. Everyone kind of like huddle in at the side and wave. Sweet, thank you for the photos. And if you want to come speak up here, or you want to sponsor, then go to cloudnativelondon.com. All the information is up there. That is it for me. I'm now going to hand over to Chris for our first talk.
Do you want to take the quiz?
I can take it with me, yeah. And yeah, round of applause.
Adjust that and that. Try and do that. Do we know if the sound's any better yet at all? Has anyone said anything? Whether it's in any way improved? Cool. Click on that thing. It works. All right. Cool. Well, imagine a thing with human faces. What a treat. I get to stand up, not worry about being on mute, kind of. Use my clicker and everything. This is actually quite exciting. Okay, so the elephant in the room, policy is a pretty dull thing, and it's kind of hard to make it sexy, but I'm going to try and at least get your attention, so bear with me. So to set the scene, I'm in a lift. Yes, American friends, if there's any joining us, we really do call them lifts. And 4 people walk in. I think to myself, Chris, this is your moment, now or never. As the door closes, I put myself in front of it, a captive audience. They're mine. I've got them. I hear the door still shut behind me, and I take a breath. I look to the first person on my left. She's in a suit. She looks really important. I gesture to her. See? She looks back at me as if to say, yes, go on. She nods. Oh, okay, perfect. The CIO, the policymaker, the one whose neck is on the block. What are the chances of finding you in my imaginary lift today? I ask her, well, what keeps you up at night? She tells me, I don't know what teams are really doing, what the volume of risk is, and what I should show more interest in. Setting and changing policy is slow and hard to communicate. And people just go off and do their own thing. They think they know better. And to be honest, often they do, but I'm then left playing catch up with the risk that they then sign me up to. Okay, I say, trying not to sound like a patronizing snake oil salesman, I can help. I turn my attention to the second person, also in a suit, looks slightly less important. I'll make a guess, let's face it, this is my imagination. It'd be weird if I was wrong. Product manager, I say, they nod. Okay, the whip cracker, I say, well, what's important to you? Well, managing risk, mostly opportunity risk, so the fear of missing out. So getting features out the door and avoiding getting bogged down with, and they glance to the CIO, bureaucracy that is seemingly designed to slow me down. Awesome, I'd say, well, this is your lucky day. I turn to the next person, dressed in overalls. I'm in a trendy part of town. They could be the CTO. Before I ask, they sense me staring at them. Cleaner, they say. Oh, okay, well, how did you get in my imagination? Let me come back to you. My attention then goes to the last person. Hoodie, headphones around their neck. My stereotypical developer. Yes, I know you well. What code do you write? I ask. Well, it doesn't really matter. Python, they say. Cool. Have you got everything updated to work with? I pause, not really knowing. Python 3 they offer? Yes, Python 3. That must be hard. They don't know it yet, but I just want a bit of their trust, which is important. Nearly, they say. Cool. Well, what's important to you? So staying on top of kind of keeping things up to date so we can react to the next fire, knowing what rules exist, what ones I can bend, what I can break, and what might cause me to lose my job. Writing consistent, good quality code, avoiding technical debt, and allowing ultimately the rest of my team to be able to cohesively work and operate as one. Do you use any tools to help you with that, I ask? Yeah, linters, code quality, test coverage tools, the usual suite. Great, I say. All right, Code 2, let's be friends. And I hand them a printed QR code and say, here's my public GPG key, so you know that you can trust what I say. I return my focus to the cleaner. I've got it. How do you get told what to do and when it changes? Well, we get a memo, or maybe something stuck to a notice board. So last week, we got a memo saying that all the meeting room whiteboards needed to be cleaned every night. Interesting, I say. Well, how does that work out? Well, it's up to us to then maintain the to-do list so that we can onboard new people and know what we need to do. Does it go wrong at all? Yeah, sometimes. So if when we compile our operational manual and we miss the memo out or we don't apply them in sequence, we get things wrong. And they glance apologetically to the product manager, like when I hadn't updated the guide that the meeting room on the 3rd floor was being used as a dedicated war room, and we wiped down all their whiteboards. I look to the dev. Sound familiar? I ask. They nod. Turns out we're not all special snowflakes, hey? All is not lost. I knew that there was a reason that I imagined that cleaner there as well. Okay, the lift is slowing. I feel it coming to its destination. Great, well, I've got a silver bullet for you too. The CIO looks to me, ready to buy whatever it is I'm selling. They ask me as the doors open, who are you and what team are you in? I say, can I move out of the way to stop obstructing the door? I answer, oh, I don't actually work here. I'm here just to fix the lift. People have been complaining that it only goes to the top floor, no matter what button they push, and it's actually pretty slow. My audience storms out, furious, heading towards the stairs, and the door's shut, and I get back to my job. Okay, so if any of that sounds familiar and you can relate to my imaginary friends, then I may have some potential answers for you. So what if I said you could update policy easily, even releasing several version kind of updates, not just in a year, a month? What about 10 updates in a single day, and seamlessly communicate that to people that needed to consume it without derailing them? You could have some visibility on compliance using tools that you maybe already use. And that policy could be readily consumable, easy to pass, demonstrate compliance, and make sense and not be bureaucratic to change when it needs to be, and ultimately not get in the way. That same policy could be treated as a dependency and operate like a linter, so you can run compliance checks locally in CI and ultimately kind of guard production. That multiple versions of the policy could be treated like a dependency as supported, so emergencies like you must update now because there's a known vulnerability type updates are a business as usual activity to communicate. Sound interesting? Okay, hang around. How am I doing for time? About right? Okay, great. We can unlock the doors now. So hopefully I've at least got a little bit of your attention. It's time to introduce myself and to start explaining things. My name's Chris Nesbitt-Smith. I'm an instructor for Loan Cates and also ControlPlane, and consultant at esynergy for the Crown Prosecution Service, and a tinkerer of open source things in general. I've spent a fair chunk of my professional career now working in UK government and large organisations where problems like these are rife. I've been promised we'll have plenty of time for questions and heckles, preferably heckles, at the end, even if I run way over. If not, come find me somewhere where there's alcohol afterwards. So, given I've got the luxury of an audience, and most of you have your clothes on for a change, thanks for that. By show of hands, who's with my CIO and has set, written, or applied policy before? Cool, so some at least. Cool. Okay, you can put your hands up. So next round. How many of you have sought exemption or consciously bent, broken, circumvented, ignored, bypassed, whatever, a policy with maybe at least some good intentions? Ha, well, you fell for it. Well, we've got all your names and employers' details down at the door. So please put your phones down, lend me your ears, the stakes just got raised. So where do I see policy going wrong? Well, before we dig into that, well, what do I mean by policy? So it usually comes in one of two forms. So security enforcing, like data at rest being encrypted, or consistency enforcing, such as code style tabs being 2 or 4 space indentated, maybe. Or maybe you can think of saying some others, but in any case, it's hopefully intended to mitigate a risk of some sort. So, however, with the best of intentions, these are often emotionally led rather than being kind of grounded in a proportionate control, which is ultimately then the open door to a case-by-case exemptions being then required when you come up against a situation that you weren't anticipating. So this is not perhaps unlike how the laws of the land are created, with case law making for a complex to navigate rule book and harder still to then measure compliance. It often then looks like the thin bit of a wedge where the precedent, which may have been an uncomfortable pill to swallow the first time round, becomes dangerous with others looking to then expand its scope, which can lead us to sometimes wonder if the cure was actually worse than the disease. But that's not how we at least typically develop software. So why does this all have to be so hard? Surely there must be a better answer. Well, we codified everything else, so isn't this the answer? Well, yes, in part, but my point of this talk is that we do it fundamentally wrong. So maybe some of you are screaming your favorite product name at me at all, or you are here indeed representing them. And you're not wholly wrong, but the devil's in the detail though. So throwing some curly braces at something doesn't inherently fix it though. Who knew? If it's a security control, it's often tempting to keep the policy a secret. Exposing it could maybe be used against you by an adversary. However, this does not typically support us shifting left at all. It results in developers and engineers effectively reverse engineering what that policy is by finding out when we smash our heads up against it. So it then therefore doesn't take much imagination to see that in the scenario of, say, an application deploy, midway through finding one of the resources is non-compliant and then rejected would leave the overall deploy in like an inconsistent halfway state, likely resulting in some downtime. Which begs the question of, was the policy better than the downtime and the impact? Especially if that then leaves your engineers, who are hopefully all plenty smart at finding inventive, should we say, ways around the computer says no response that they've got. This is then further exacerbated when updates to the policy are desired. Maybe you get a pen test, something goes wrong. So you form that case law and need to apply a new policy. So maybe all S3 buckets now need to be encrypted, a change that could be potentially considered breaking. Sure, you might say that you provide warnings on at least the less important or critical issues, or perhaps on new emerging policy, which is great, so long as someone sees them. But if you've adopted GitOps or at least CI/CD, is anyone seeing those warnings? Who studies the results of a successful build log every time? Anyone? Every time? Well, if you are, I'd politely suggest you're probably missing the point of CI/CD. You should ultimately be able to trust the job status. Okay, well, I'm not here just to throw stones. A little bit, not entirely. So remember my implied kind of promises to my four imaginary friends of what the promised land might look like. Well, there's nothing new fundamentally under the sun. We've all unwittingly solved these problems elsewhere. We just need to be reminded and join the dots. Well, the first thing is something, if we're already doing policy as code, you might already be doing, which is put it in version control. So the thing that you might not, however, be doing is actually then surfacing it and making it visible. So at least in a source list, by which I mean allow anyone within your walled garden of employees and suppliers to see that policy. I'm not saying kind of give away all your threat monitoring and intelligence away. You can probably keep that to yourselves. But I'd argue visible policy and the gaps therein is often better than kind of downtime, reverse engineered workarounds, and opaque legacy exemption spaghetti soup. If you're brave, you might even open source it. You'll find it unlocks the ability to work well with prospective suppliers without NDAs and whatnot, and widely distributed secrets are expensive to maintain, difficult to handle, and often only stay secret for so long after all. Okay, well, we're off to a good start. Our policy is visible now to those that need to see it. So many of you are no doubt used to semantic versioning, but a quick recap. The first segment is used to indicate breaking, perhaps conflicting changes. So for the sake of policy, that's in that context, let's say that we're requiring resources to have a department label. Maybe that will help with some internal cross-charging. Who knows, I'm not really judging. An increment to that might look like requiring that to be from a predetermined list rather than being free text. Second segment is used to indicate minor changes that shouldn't break anyone. So an increment to that in this case might look like correcting a spelling mistake on one of the department labels, maybe. The third segment is then to indicate a patch change. So these should be a no-brainer for anyone to keep up to date with. An increment to that might look like adding a department to the available options. So, okay, so our policy is visible in a repository, it's versioned so we can easily communicate it, we can track on release notes, and expectations are all managed by semantic versioning. In software, we're used to handling dependencies. So what if your policy was actually just another dependency? So you might unwittingly already be doing this if, for example, you have, say, ESLint as a dependency within your JavaScript package, maybe. Okay, so our policy is visible in a repository version. We can easily communicate it. We can tap on the release notes. The expectation managed by semantic versioning, beginning to look a bit more like software. Okay, I'll level you. This is a dirty word in this space of infrastructure and things like that, right? Testing. But in order to make this an asset that everyone can depend on and also provide some known good examples, tests are fundamentally essential to give everyone some confidence in the stability and surface potential side effects before they ultimately hurt everyone involved. Consumers of this policy need to be able to test themselves against that policy locally and in CI/CD, thus shortening the feedback loop and better informing everyone. So as a bonus, we should be able to find that our consumers are able to rely on the artifacts that we're sharing with them. Well, we're well and truly on the home stretch. It's a dependency, so updating it should be no different to any other. And we can reuse some magic like GitHub's Dependable or MEN's, we used to be white sources, Renovate to do that for us. So think automatic pull requests, tests, even auto merging if you like. Okay, so to check you're all awake still, can anyone tell me a recent event that caused people to want to know what version of a certain logging Java doohickey that you were potentially running literally everywhere in the estate? Someone shouts it out to me. The first person that shouts it out gets a t-shirt. Fine. Come find me in a minute. They are fabulous t-shirts. Cool. So yeah, as you know, all presentations this year are actually contractually required to reference log4j in some form, even when it's almost entirely out of context and includes some memes. So in just a few short months, I can finally remove these and hopefully just point broadly at a list of scary looking CVEs in order to command your behavior through some fear. What I'm getting at here, though, is the situational awareness piece around software supply chain is something that your organization is hopefully already thinking about, if not already addressing. So if our software is a dependency, this is at least not a new problem. Software bill of materials for the win, right? I'll let Liz get his picture. Thanks. You all right? Someone wants to make me a better picture of that, that'd be awesome. So, which can allow us to measure the compliance then across the estate. Okay, so I just covered quite a lot of ground and hopefully sounded at least vaguely convincing, and this isn't just a fictional utopia painted in PowerPoint. So it's time to look at how you might be able to do this. And I know you really just came here wanting to see a million words on a slide, not just the odd emoji or two. So we've reached the point where I get to show you some code. Hooray! So to maintain scope, I'm going to limit this to talking about two things to prove that it's not just one tech or one tool. I've arbitrarily picked Terraform and Kubernetes, but I could have fundamentally picked anything, been thereabouts. Naturally, I'll need some tools to go along with this. I'm too lazy to invent anything here after all. So likewise, I'm going to pick two, but again, this could be some or even all probably. So in this case, Chekhov's going to be doing my Terraform and Canervo's going to be doing my Kubernetes. If you want to browse along with me, I've created an example GitHub organization. I'm not expecting you to read or grok the code on screen. Don't worry about it too much. It's just to prove that I made a real thing. So the policy is stored here. So here's where my policy starts at version 1.0, an abridged bit of it, but probably can't read it anyway. So I've got policy here that requires a department label on all resources. So long as it's set, it doesn't matter what it is. I've written tests for this, so note how the passing test cases are useful as a great example about what good and bad looks like. We pushed a tag in Git where we've added release notes. I can sign it to provide further assurance if my heart so desires. It does, obviously. Moving on, version 2 looks similar, only now that department field has to be one of a predetermined list. So like before, tests exist, release notes are written, tags are signed. 2.1.0 is where we notice and correct a spelling mistake of one of the options in that list of departments. And 2.1.1, and 2.1, I've now added a new department to the list. There's a few other repositories in that organization. So app1 and infra1, they depend on version 1.00 of the policy. It is not compliant with version 2 or beyond, but how do I know that? Well, I've configured Renovate to automatically make me a pull request. So when there's a new version of the policy, it's super obvious if I can update my dependency. And I can also see clear feedback about where and why I'm not compliant. I can also see all of the pull requests over my org, so I can therefore manage the compliance of my policy. Moving on from that, App 2 and Infra 2 depend on version 2.00 of policy. However, we could merge the open pull request all the way up to 2.11. And finally, App 3 and Infra 3 are all dependent on 2.11, and they get a gold star from the CIO. There is a small touch of magic in this, and it's not pretty. I've written some bash. Don't judge me, even though I've probably definitely written worse. What this does, however, is it allows me from my dev laptop or in CI to evaluate my code against the version of the policy. Ideally, this might be less cumbersome, but it is what it is for now. Pull requests and collaboration are all very welcome. And the last piece of the puzzle is managing the life cycle of the policies and allowing multiple versions of the policy to be accepted and evaluated within a single runtime. This is key. So I cheated a bit here, admittedly. Kubernetes gives you admission controllers. It's not so easy to get, so far as I've found, the same policy evaluation in cloud. They've got their own policy evaluation. Trying to run that locally doesn't seem to be terribly easy. I've not fundamentally figured out a way to do that properly yet. Again, pull request contribution, all very welcome to try and address that. So you may have noticed the way policy, the policy I've designed is, and it's designed in Kubernetes, lends itself well to coexist with each other, which brings us to cluster 1, which describes a cluster that accepts all of the versions of the policy that we've described so far. Likewise, cluster 2 only accepts versions 2.00 and greater. So we can automate using Kind for CI to deploy the apps. And there we have it, all a full org, all done, all compliant, policy, all versions, CIO, all aware of what's going on. So this is great, right? But just one more thing. Wouldn't it be awesome if the policy carried a story about why it exists? After all, if your agile team is even half effective, it will reject anything that it perceives as friction if it doesn't see the value in it. So this could allow our devs to know why they're compliant. And if they want to do something outside of what the policy permits, they don't need any sort of exemption granted per se. They can then have a well-reasoned and informed debate with rationale behind a pull request policy. So imagine, if you will, this going through a stage of versions with risks that inform the mitigations, manifested as policy, all maintained as one. So when the risk landscape changes, your policies can move with it. So when some new privacy regulation comes out, or your latest marketing strategy pays off and you require, say, maybe more data, for example, even if your policy was perfect at one time, the risk and the appetite for it will stand still for no one. We can liken this to over-provisioning that we might be familiar with elsewhere, where lead times are long, change is hard, and there is significant pressure in nailing it the first time, which can lead to hedging bets against what some future state might be, rather than proportionate mitigation to the risks that are more tangibly real in the now. That's where the real culture change is needed, and the execution of that is likely a long series of talks in of itself. So now this is really over to you. Honestly, the best thing that you could do right now is tell me this is madness. It's already been done, it's irrelevant, or otherwise just unachievable, or something my esteemed echo chamber of peers have yet to do. But beyond making pull requests and developing the theory more, I'd really like to start building a case study with a willing organization and allow me to swap my imaginary friends for some real ones. But the most important thing I want to you to remember from our time together is that, and feel free to say it out loud with me, purposeless policy is potentially practically pointless policy. I've been practicing saying that far too many times. So I've been Chris Nesbitt-Smith. Thanks for your time. You're now free to leave. I'll destroy all the evidence of your guilt admissions earlier. I will, promise. Like, subscribe, whatever the kids do on LinkedIn, GitHub, whatever. And you can rest assured there'll be little to no spam or much content at all. I'm simply awful at self-promotion, especially on social media. cns.me just points at my LinkedIn. Talks.cns.me contains this and other talks, and they're all open source. Questions are very welcome on this or anything else, so I'll hold the stage for as long as I'm allowed, or find me afterwards. I'm pretty thirsty, so after I finish, I'll be winning some alcohol somewhere soon. I have, apart from the one, I have three more t-shirts to give out to the first questions, if anyone's got one, but at least in person. Can't quite bundle them to any remote ones.
Cut in there. You're right.
Tag someone with your name.
I am. I don't think I've ever tweeted, but I am on. Apart from my key-based GPG key, I think that's the only thing I've ever tweeted. So yeah, don't expect to see anything there. But yes, that is me, Chris and S. Hello.
You mentioned you've written some bad bash. Where can I see this bash code first?
On github.com/policy as version code. Not sure you get a t-shirt for that one, Liz.
So for me, obviously, this is gospel. I'm actually one of the early guys behind Calico policy, network policy, the CA policies. I've been preaching the past 3 years. We have helped a number of organizations. I'm kind of curious as to what you see in the real world today as being an organization, because this is obviously where we want to go. I mean, go further than this, but in the real world, people like to say, people find, hey, there's a cut that let's just skip this for now. Oh, it's going to slow me down. Skip it. What do you think?
So I'll try and repeat the question because the mic's up here and I forgot to turn the one on in the room before you spoke. An abridged version of that, and I'll answer it and let me know if I've not repeated it correctly. So it's like, where do you see this in like the real world of where policy currently stands, like the status quo? I guess the fundamental point of my talk is, and the piece is that the premise of that we do it wrong. So yes, we've got all of the kind of tools to do policy, but we make some largely emotive-led decisions around how and why we apply it, and we've kind of got a reverse it back to like a more dictatorship and controlling command and control point of trying to dictate what policy is, and ultimately it hurts us, right? It hurts us by then having to grant exemptions to that policy. So the point of this is, and the premise of that is that you can, rather than just having exemptions, you can make a defined bit of policy rule that says, well, you can do this as so long as these other conditions are met on the thing you're trying to do. And it's all codified. Therefore, you're not trying to track what teams have got what exemptions for how long and all sorts of other things. Attestations, I think, has been like pushed as maybe as a potential method, but again, like that. At least my opinion on that and belief is that like having lots of attestations that you need to make still puts you into a hard to place position on actually what the policy is and how that moves. So the whole point of this is mostly to move towards making updates to the policy seamless. So rather than trying to hedge your bets and trying to write a really restrictive policy and then granting those exemptions, you've just you can move it quickly. And then the other key bit is being able to have a runtime that supports multiple versions. So you're not dictating that everyone all has to upgrade to the new version at one point.
I guess clarify. I mean, everything you said is absolutely true. I guess my question really is, my experience, I probably see about 10% of organizations following that. What's your experience been?
What in terms of organizations following any policy or? I mean, we all held our hands up and said that we bend policy, right? So yeah, it doesn't really work very well, which leads my CIO friend to not having a clue about really what's going on, which is a vulnerable position to a CIO ultimately, and the person who's actually is holding the risk. If data leaks happen, they're then the ones that get brought up with negligence, and certainly within like UK law, potentially stand to lose their house, right? And the fines can get jumped over limited liability of the organisation and land on them if they are found to be negligent. So it doesn't happen as much as it should. I think that might be at least partly the problem of the place that we've kind of got to. Optimistically, I'd like to think that like doing some of these things might actually at least help landing small bits of policy incrementally and allowing that to grow and an organization to grow with it, rather than what typically happens as someone saying, here's a load of policy, try and do this, and then quite quickly finding 3 months later down the line when you've tried to actually do it for real, everyone's got exemptions and it doesn't mean anything, and who knows actually what the value of the whole policy as a whole was. Oh.
There are many products today to try, and that's really what you should have. But always seems like they never try and follow that rule. They always seem like they have rules built into the network. They don't really follow like source code changes like that. I wonder if you see that kind of like change for example, that
It'd be nice. No, I've not. I did try and do some research. This part of the point of this is like, tell me that it's done elsewhere, and I'll shut up and let them, hopefully with a louder platform, actually preach it better. I've not, frustratingly, kind of seen this done elsewhere, and which is why it seems frustrating, because it, as a developer at heart, like it feels like, well, obviously you'd version it, obviously. Why wouldn't you do that? And you kind of see it a bit, as I touched on, with like if you depend on like a linter, like and you have that in like your package management, that's going to be versioned. So if you use things like dependable or renovate or whatever, it will make you a pull request that tells you when that linter updates, which comes with new rules, right, and that are built in. So you fundamentally get that, and you'll see that if you then have something that doesn't breaks the newer version of the policy rule that's coming in, then it's you can't merge that pull request to update it. But that's the only place that I've actually seen this in anger, not on like any infrastructure-y policy, or indeed clean the whiteboards or whatever, like as a thing of actually a clear definition of a versioned history of things. Oh.
Yeah. Any experience you have when when there are existing microservices for containers running, when you introduce this model, developers don't know what is going to break, and you don't have the confidence in what is the plan, because you don't know what is going to break and what is going to happen.
So the question is, how do you like land this as a kind of brownfield installation, right? I guess.
Then it's already running.
Yeah, so you've got like stuff running, maybe you've got some policy or whatever, and you try and land some new changes in. So the whole point of this is that it's intended to be a soft touch. So not doing what many of the vendors do of like simply providing a warning. It will stop, but you start with a position of like your version 0.0.0 or whatever a policy is entirely permissive, right? So no rules, everything goes, and then incrementally work up from that. So you got your 0.01 or whatever until you get to a 1.0 baseline. You can increment up and see what people are doing and try and kind of nudge your development teams in the right sort of direction and see what the impact is. So if you've landed your 0.0 with complete permissive policy everywhere, you can then start rolling version updates and have more awareness of what the consequential impact of those changes will be, simply by writing the policy and running the tests against the static analysis of their code.
The application is a policy.
Sorry?
Who owns the policy?
You own the policy. Yeah, ultimately everyone owns it. Like you make a pull request to it. So an app team needs to do something. So if the policy says, I don't know, like all S3 buckets need to be encrypted and they can't be public. Some team wants to use an S3 bucket as part of a CDN. Perfectly good answer, perfectly good solution that they want to do. And that will require a amendment to policy. Well, that's fine. They can make a pull request and have a well-reasoned debate around what that policy is. Ultimately, the CIO or whoever that they delegate it to actually sign that off. But the changes are well articulated and in the open communication about what that is, with a well-reasoned debate about why and how and what mitigations to the original risk that was there to protect against. Cool.
Question.
Yes. Yeah, so that'd be awesome, right? So I mean, the pipeline is what will so the repository itself picks points at a version. So the only time that you'll ever get a breaking change, presuming that you've not done something that's non-compliant with the version that you've already signed up to, would be that. So you should be able to do from your local machine with the repos that are there. You can evaluate the policy locally, so you can do that. It's not pretty because it looks at the version of the policy that you're dependent on, pulls that, and then runs it. Feel free to make that better. But so that's a bit slow and cumbersome, runs as a container and it's ugly. But fundamentally works, and the same thing gets run in CI. This isn't intended to block like production pipelines. It's intended to nudge in the right direction and provide visibility of what the team is then compliant to. And then, yeah, obviously, if you want to have like pre-commit hooks or whatever that ran the same as like your linters and your code styling, whatever, and unit tests and everything else like that before you commit or put it to a merge branch point, then you can do all the same checks there. But like fundamentally, the point is trying to get your policy evaluation closer to a linting type thing that we're kind of used to seeing for static analysis that we can do quickly and easily locally. Well, yeah, or roll back, but at least you can see that you're not compliant with version whatever the thing is. And you can then do something about that. But yeah, ultimately provide someone the information. Same rules apply that if you're not compliant with a newer version of, like, if it's JavaScript, say ESLint or something that's now got a new baked-in rule that says whatever in the rule set, like all of that is already an existing problem. I'm not trying to suggest adding to the stack of problems that we have. It's like just reduce, like at least it's the same one that we already have in trying to maintain currency on our dependencies.
What is the end goal like in terms of like had it for a while and yet what's your expectation in terms of the amount of time it's taken up by like code, re-releasing code that might not be required?
The greater, I'd say, what do I see the impact of this being kind of as a long-term thing? I don't know. Like, I need to actually see an angle to do it. I guess as a utopian vision of what I can see my baby doing if it's allowed to kind of go and breathe somewhere, would be like the seeing that evolve, and it will be interesting. And the main thing is that it may feel like it might be using more time, but the overall point is that there's more visibility and more rigor. Ultimately, this shouldn't feel any different to linting your code, and we do that already, right? So what do you mean re-releasing? I mean, you're
currently not for example, checking best practices.
Sure.
Only spot later on with the CIO will hang on in that bucket.
Sure.
Yeah, I mean, re-released it again with the new configuration.
Sure.
That's going to take time.
Yeah, but by doing static analysis, the same as the unit test, you brought the visibility of that closer, right? So if the existing policy already was that don't leave a bucket open, then before they go and make the bucket open, so whilst they're still in the mental context of writing the Terraform or whatever it is to make a bucket, if they have the same things that they have the linting in any other case, they can evaluate and go, well, it should be according to the policy over here, has to meet these rules, then happy days, right? And you've got your examples of what is best practice, what is not even best practice, what is valid code in the tests for the policy. Cool. I've burnt out.
No. I think we're just trying to hand over to Rick. So round of applause, please.
2 seconds to get on.
All yours.
Should take the work. Just the task quick.
Right, so it's oi. Good evening, Cloud Native London. Hello to everybody in the room and joining us online. I've been sat there thinking, how am I going to follow that? I'm talking about trust and workload identity, and already I'm thinking it's not going to be as exciting and cool and interesting as policy. Which way are we going to clicker? So I am Rick Featherstone. I'm an engineer at ControlPlane. That's my handle. which is ironic because I haven't actually said anything. I've just started doing this public speaking stuff. And my boss was saying to me, "You need a Twitter account." I was thinking, yeah, the stuff that the one that I'm already using is probably not corporate. So I've got a new one, and I promise I'll start putting some stuff on there soon. I work for ControlPlane. We're a cloud native security consultancy. We do security audits, pen test, consultancy, training, that kind of stuff. But I'm not here to sell you anything. I'm here to talk about these things on the left there. So this is what a claim I'm going to talk about this evening, and this is what you need to judge me against. I'm going to talk about a little T dangling on the end there. Talking about trust. In the context of secrets management and access control, with a focus primarily on machine identity. So what it is, how do you get one, and some of the things you might already know. Hopefully, some of the things you won't. Otherwise, it's not a very interesting talk for you guys. And hopefully, it'll give you some stuff that you can maybe take back to your day jobs and use in the future. There's a lot to cover in 30 minutes. Not as much as Chris just covered, though. What an impressive number of slides. The cartoons at the beginning were fantastic. So, pre-cloud. Some of the things that we used to do. So, I mean, things were fairly static. We'd order hardware or we'd order or VMs, and IP addresses would be statically allocated. So we put IP addresses in X509 certificates and use those for identity. Firewalls would use IP and port combinations to control access and communication. Secrets and certificates would have been manually deployed onto machines by admins or maybe using some configuration management tools. But then kind of cloud computing came along and fundamentally changed the way that we do things. IP addresses are no longer a useful identifier. Your workloads and your hosts come and go in this dynamic cloud environment. Your workloads can get different IP addresses. They can have multiple IP addresses at the same time. Secrets distribution becomes a much harder problem now that we've got much more hosts and the workloads running all over the place. And with more services wanting to talk to each other, the old IP and boundary-based approaches to locking things down, they no longer work. So secrets management solutions help with the secrets distribution problem. In order to securely access those secrets, we need a secret to access the secret management solutions. So now we've got it's turtles all the way down. And they call this initial secret, they call it secret zeros, this initial secret that you need to get access to things. And that's synonymous with workload identity, this thing that your workloads can use to prove who they are to other things. And so what do we need? So we need a trusted third party issuing workloads with their identities. And we need a way for the subjects to retrieve their identities in a secure manner without the need to possess any secret material to start with, and potentially without any knowledge of the identity that they're asking for. We want those identity documents to be short-lived, and we want the acquisition and replacement for our workloads to be seamless and simple. And we need a way for our relying parties to be able to verify the correctness and the validity of these identity documents. And so the basis of that verifiability, the cryptography, and the format of choice for these identity documents are JWTs, JOTs, and X509 certificates. So the secret zero sounds pretty good, doesn't it? But you're wondering how you can get one. Who's running workloads in Kubernetes? Which of hands? Yeah, it's kind of about half of you. Some good news. If you're running the Kubernetes, you've already got one. Have you heard of the token review API? Yeah, nice. So we'll start with something simple, something you probably already, and then we'll kind of build up as the kind of requirements for that change. So, got two Kubernetes service accounts, subject reliant party. They've both got a service account token. The subject makes a request to the reliant party, sends its token in the authorization header, using a secure channel to prevent interception and replay attacks. The reliant party then makes a call back to the Kubernetes API server, passing the subject's token. and then Kubernetes will verify the token and then return information about the subject back to the relying party. And then in that response, we've got information about the subject. So we've got the username there, and we've got the group. So we can now use this information to make authorization decisions. So that's the token review API, and that's the most common way of integrating Kubernetes workloads with HashiCorp Vault. You guys are aware of HashiCorp Vault, secrets management. So we've got Kubernetes workloads, authenticating HashiCorp Vault, and now we can get secrets, passwords, certificates, things from Vault. That's pretty cool. And if you're working in a single Kubernetes cluster, this works quite nicely. You could even build something yourself on that token review API if you need to simple, just using the service account tokens that Kubernetes is issuing to your service accounts that are running your workloads anyway. Don't use long-lived service account tokens. Now, prior to Kubernetes 1.21, the service account tokens existed for the lifetime of your service account. They were replaced if you deleted the secret, but they weren't rotated. And we want to basically restrict the usefulness of a compromised token. So we use bound service account tokens. They use the projected volume capabilities. So there's sometimes you hear them called projected service account tokens, but they're bound by audience and time. So an example here, if our demo service is malicious, it can't use our token to impersonate us to any other service because we've restricted the audience to the demo service itself. Now this all kind of works within a single Kubernetes cluster, but if your workload's running Kubernetes, the Vault's sat outside your Kubernetes cluster, you need to prior to 1.21, you can just create a regular service account token. After that, you need to create a long-lived service account token, and then you need to somehow securely share that with HashiCorp Vault. So HashiCorp Vault can then validate your service accounts tokens to get access to secrets. So now we've got a secrets management problem again. How do we deal with passing that token around securely? Is there a way we can do this without needing tokens? So can we validate tokens without needing to authenticate? And sorry. Well, unsurprisingly, we can. So the service account issue discovery functionality was added to Kubernetes in 1.12. It's stable since 1.20, and it's basically built on top of the OIDC discovery. This is not, hands up if anybody in the room has heard of this before. Pretty good. So kind of in my experience, not many people tend to know about this, but it's pretty cool. You've got your service account's got a actually let's have a look at some tokens and we can talk our way through it. So before we do that, we need to know what's in these tokens. So who knows what the serialization format is for a job? If you want to look at the information in the job, what do? You copy and paste it into jwt.io.
Oh, there's a CLI.
Pardon?
There's a CLI.
It's even simpler than that. Shouldn't really, especially production, so you shouldn't really be pasting them into anything on the web to find out what's in there. But it's a really simple serialization format. So it consists of a header, a payload, and a signature. They're base64 URL encoded, separated with a period, and that's basically it. So we can now pipe it through JQ to have a look. So there we're finding out the payload. So we can look at the payloads, which is kind of where the most useful information is. We can look at the header. We can't do the signature because that's not UTF-8 encoded, so it doesn't work. We're only sort of really interested in the payload and potentially the header. So no more pasting your tokens into JWT.io. Okay, you're welcome, everybody. Take a little picture of that one. So what's next? So that's a decoded token. Top there we've got the header, so we've got the algorithm for the signature, which is down at the bottom. and the key ID up at the top there. We'll come back to that later. And then in the payload itself, we've got the basic claims that we've got inside that token there. We've got some stuff around the life cycle of the token, so when it expires, when it was issued, and then we've got information about the subject and the audience. Key to OIDC discovery and the service account issue discovery stuff is that issuer field, and we basically take that issuer field, pop the well-known suffix on the end, and that gives us the discovery document, and then from that we get the key set, and then we can get the keys and verify the signature, and then we know that we can trust the claims in the token itself. So what does that look like? So just to kind of reinforce that, we'll have a look at what it looks like in the major cloud providers. So we've got a GKE token. Take the issuer there, append the well-known URL onto the end of it, and get the discovery document. So we've got some metadata there. The key thing there is that JWKS URI at the top there. We take that, and then we can do a get, and then we get the key set. Only one there at the moment, but over time, as those keys are rotated, that array will grow, and that's why the key ID is important. You get the right one, so you verify the signature correctly, and we can reconstitute the public key from the modulus and the exponent there, and then we can verify the signatures. In AWS, same sort of thing, slightly different metadata. Get the discovery document. From that, we can get the key set, and then we can verify the token. And again, in AKS, notice the trailing slash on the issuer there. So if you're building something yourself, because I mean, it's just a simple protocol. You're just doing decode the token, look at the issuer, do a get with the well-known URL on the end of it. Get the JWKS URI and do a get on that. You can build something yourself. You need to be aware that sometimes you have a trailing slash, sometimes you won't. So you need to remove that if it's there. And then the key set is the discovery document, get keys, and then get keys, get the key set, get the right key, and then you can decode your token. So that's all very well. But what can you do with it? That's what you're here for. So basically, you can use it with anything that supports OIDC discovery. So all the major cloud providers will support Web Identity Federation with their IAM. So you can configure your OIDC provider as your Kubernetes cluster, and now you can swap your service account tokens for temporary cloud credentials. And you're not limited to, because it's OIDC, you're not limited to the cloud provider that you're running on. So IAM roles for service accounts in AWS, the RSA stuff, they provide a mutating webhook. So you can deploy that into a GKE cluster. Then you simply annotate your service account with the IAM role that you want to get credentials for. And then when you deploy a pod into your cluster, the webhook will mutate that. It will add the bound service account token for you, and it will add the required environment variables. And then your workload can just use the API, the AWS APIs to talk to AWS, and that authentication and get those credentials just happens automatically for you because it's done with the default credential chain. So it just kind of happens auto magically. Now that's super cool. Yeah, Azure's kind of similar. Google, so we can do that. We can use policy to enforce access control between services trying to talk to each other. So we can verify the token and then make policy decisions based on the subject and the audience. In that example, just trusting the issuer. Probably want to maintain a list of trusted issuers if you're doing this, and check that it's a trusted issuer. Otherwise, anyone who's handing out OIDC tokens can talk to your services, as long as they get the subject or the audience right, depending on what you're using there. Your identity provider doesn't have to be Kubernetes. It could be any OIDC provider. It could be GitHub. So you can run your infrastructure as code pipelines in GitHub Actions and get temporary cloud credentials without having to store them in GitHub. So you create a, in this example, this is GCP. So you create a service account GCP, create a workload identity pool, configure the OIDC provider, and then allow the service account impersonation with a binding to that service account. Then you can use the GitHub, the Google GitHub auth action, and you can get tokens. You get token in various formats. You can get an access token, which has got kind of authorization information in it. You can get a credentials file, which is the same as your regular JSON service account credentials file. Or you get an ID token, which I've got here, because it's the same as the JOTs that we were looking at, and we can then pipe that through JQ and have a look. And it's a similar set of claims to the tokens that we were seeing before. The subject field there is the OAuth to client ID for your Google service account, and you can check that in the console and verify that it's the same one. But now you can do stuff. You can be getting temporary cloud credentials from your GitHub actions, and doing stuff there. So that's all well and good. But what if you need more than that? What if you want meaningful user-friendly names for your subject, rather than that long arbitrary kind of number string that you get from Google there, or the Kubernetes service account name for your Kubernetes clusters? What if you want to use the same identity across multiple clusters, potentially across multiple namespaces? Or if your clusters are regularly repaved and the issue URL changes, and you don't want to have to reconfigure all of your OIDC providers that use that. You want to simplify the validation of the identity between your workloads running in your cluster, instead of having to implement yourself, but doing the OIDC discovery calls. You want to just have the key set or the keys or the certificate, sorry, and then just be able to verify the JOTs that way. If you want to extend your trust domain across multiple clusters, so you want to have separate trust domains, but you want them to be able to verify the keys across that. Or maybe you're not even running in Kubernetes. Maybe you're running on VMs or IoT devices. So you need more than just these tokens issued by your Kubernetes cluster. And that's where Spiffy and Spire come in. Spiffy defines the standards for an identity framework. Spire is the reference implementation of those standards. So the key things to know there is Spiffy ID, the identity there. It's the format of the identity. It's basically a URI. So using the Spiffy protocol there. In this example, acme.com is the trust domain, and then billing/payments is just an arbitrary string to identify your workloads. So now you can start to use names that kind of mean something and are kind of human readable. The SVIDs, they're the documents themselves. So we can get the JOTs, SVIDs as JOTs, similar to what Kubernetes is handing out. So we've got a migration path there. We could start on Kubernetes, and then we can move to, as long as we're using the OIDC kind of thing, we can then move to putting Spire in if our requirements need that. Or we can get X509 certificates. Let's say we wanted to have the same. So if you were just kind of running using Kubernetes, you've got a service mesh just handing out certificates for mutual TLS, and you're using your JOTs for your authentication. What if you want the same identity in your tokens and your X509s? Or you can get them both from Spiffy, so you get the same identity in there. You're getting the trust bundles there for both the JOTs and the X509s. That's the certificates that you can use to verify these identity documents. And the workload API defines the protocol for your workloads to securely retrieve and potentially verify the SVIDs. So with Kubernetes, Kubernetes knows the identity because you're using the service account. So that's kind of already known. How does Spire kind of figure this out? Well, Spire's agents that run on nodes, and they attest themselves to the server, and then your workloads attest themselves to the agent on the node that they're running on. And then we've got kind of registration based on selectors that kind of map the metadata depending on the attestation that you're using to a specific Spiffy ID. And you map, so you can now map the workload Spiffy ID to a parent Spiffy ID. So now you can tie your workloads identities to specific nodes. So it can only run on these specific nodes, can only be obtained workloads running on these nodes. So this is a list of the various attesters. On the left, the node attestation, that's the agent to the server. Top three are pre-shared secrets, a token generated by the server, X509 or an SSH certificate. The next two are if you're running on Kubernetes, service account token, and a PSAT is that bound service account token. And then the final three are your kind of standard cloud identity documents. And so you can use these for your agents that are running the workload API to attest themselves to the Spire server. Now your workloads running on those nodes can use the attesters on the left to attest themselves to the agent and therefore get their identities. So some of the metadata that you've got, if you're running on Unix, you can use things like the user ID or the username of the process, the group ID, the group name, the path to the binary, the digest of the binary, things that you kind of know about that workload up front. If you're running on Docker, you can use the image ID, the labels, environment variables. And on Kubernetes, kind of usual things, service account, namespace, image, those kind of things. And this kind of metadata, you then map that to the spiffy IDs that your workloads, and they'll just get them by virtue of running in that environment and matching that. So what might a deployment of that look like? So running on a single Kubernetes cluster, the Spire server there, the agents would use the projected service account token attester to attest the server. Workloads we use Kubernetes, and then we'll map those identities. The OIDC discovery provider, that's an optional component, but we've got it in this diagram so that we can, and that will expose the discovery document and the JWCS URL endpoints. So we've got that in there to kind of show that it works exactly the same as the service account issue and discovery stuff that we're looking at. So we'll quickly have a look and see what that looks like. And unsurprisingly, JWTS vids look exactly the same as the JOTs that Kubernetes is handing out. And the discovery document looks very similar. And so does the key set. So it's the same sort of thing. And as I mentioned earlier, you've got this kind of migration path. You can start off just simply with Kubernetes cluster or multiple Kubernetes clusters. And then as you need more, you can slip Spire in and then just replace it and just point to the JWTS vids rather than your Kubernetes service account tokens. So I said we can use X509 SVIDs. We kind of focus mostly on JOTs so far because you get those for free with Kubernetes. You put in Spire in, you've got a administrative and an operational overhead, but your use case might need you might need more. You might want X509s and JOTs to have the same identity in them, and so yeah, using Spire will give you that, and that's kind of what it looks like. So we can see that we can use this for server or client authentication. So we can use these X509s for mutual TLS, and then in the URI SAN there, we've got the spiffy ID. So I did say something about hardware root of trust, and that's because that's what my boss keeps telling me to talk about. Now, everything we've talked about so far is stuff that I've kind of been doing over the last couple of years, and I think it's super cool and really interesting to kind of share because some of the stuff people just don't know about. The rest of this deck is kind of forward-thinking stuff, looking at where I kind of think workload identity is going. There's a lot of kind of interesting stuff going on where you want to sort of physically tie things down to a specific machine, so that people can't get like an X509 certificate or an SSH certificate and steal it, put it on another box and impersonate the box. We want to tie this down to a specific. So these are kind of some of the things that I think are certainly worth knowing about and starting to look into, because I think this is an emerging area and it's going to be loads of stuff in this space. So TPMs, Trusted Platform App modules, hands up, who's heard of those? Most people got, if you're running Windows, you've got one running there with your BitLocker stuff. It's basically a dedicated crypto device. You can use it to generate keys, perform cryptographic operations. The cool thing about it is the keys can't leave that TPM unencrypted. So you generate the keys in the TPM, you can get them out encrypted, but in order to use them, you need to load them back into the TPM. So they're tied to that TPM, that actual TPM on that machine. So now you can't take those keys and use them somewhere else. And we'll talk about that a little bit in a sec. TPMs have also got these platform configuration registers, which are special registers that you can read, but you can't directly write to. They store hash values, and the hash value is the old hash plus the new measurement. So it's it's kind of a chain of trust. And then when you tie that to the IMA system in Linux, you can now start to verify that nobody's tampered with your machine. So you've got a value in that PCR based on all the files that you're monitoring, and that's what Keyline does to continuously verify machines that it's tested. Have a look on their website. They've got a really cool example of removing a compromised etcd node from a cluster. So that's certainly worth looking at. In the Spire space, this is super cool. I found out about this a couple of weeks ago. It's been in the code base for about 9 months, but it's not on the official documentation yet. So I'm not quite sure if this is officially supported, but it's super cool because it's using that TPM, and you're creating a local device ID, which is just a private public key and a certificate in that TPM, and then they come out encrypted, and then your agent is using those to verify itself to a server. So it's got to load them back into that TPM, and then there'll be a challenge between the server and the agent. And now you really know that that agent is who it says it is, because if somebody's taken those keys and put them on another box, well, it's not going to work. They can't use those keys. So that's kind of super cool and really interesting. There's a lot of cool stuff in that space. There's also trusted execution environments, which is kind of similar to TPMs, kind of lockdown, try to remove get down to the kind of lowest trusted compute base, get away from OS and hypervisors and all that kind of stuff, right down to the hardware. I think these are kind of the areas where it's kind of worth starting to have a look at, because there's a lot of kind of movement into that sort of space, and a lot of cool stuff going on. So that's it. So key takeaways are: you've probably already got a workload identity. Can use your Kubernetes cluster as your identity provider. If you're using service account tokens, use the bound service account tokens. Post version 1.21 of Kubernetes onwards, it's already I only found out the other day that it's already doing that for you. So your service account tokens are being regularly rotated anyway. The audience is the Kubernetes cluster. So if you're kind of using your tokens outside of your Kubernetes cluster, you want to create a new token for each use case, so that you can specifically tie them down to that specific audience. Always use a secure channel if you're passing jobs around as identity. OIDC discovery and web identity federation, super cool. Getting temporary cloud credentials, especially with IRSA for free. Consider Swift Inspire if you need more than you can get from a Kubernetes cluster, and look into TPMs, Keyline, and trusted execution environments. And that's me. Any?
Unfortunately, out of time questions. But I guess people can find you.
But yeah, we're going to take a break now anyway, so people can come up, wander over, and if you've got any questions.
Exactly. So we've got a 15-minute break now. For people to get up, stretch your legs, grab more drinks, pizza, whatever. I think there's bathrooms around the corner there as well, but come back at 8:30. Thank you. Sorry, I was
No, that's fine.
trying to out like. Oh, thank you so much. Let me just check. There we go.
Fair enough. But yeah, you'll need to do that and then that.
Most important. Let me try and manage that.
Ah, you are. I thought it was also like, oh, which is Mark. Camera is like following. You are the that one to make.
There is level software.
Yeah.
Yeah. If you wanted to, please remember that none of us have done so far. You can push that button, which opens the mics in the room.
Sorry, what? Sorry.
Yeah. You push the red button, it opens the mic in the room. If you want to. Yeah, you can be more bothered to remember it. But
Yeah, I will try.
Alrighty, we are back, and I should be talking to the microphone here, but I would like to welcome Bruno. Please.
Hey. So, hello everyone. As you probably see in the slide, and thank you for being online here. I'm Bruno Silva. So, if looking for any social network, I'm not so fancy. I don't have my own website. I just use about me/PG Silva IT. What we're going to talk today is called native runtime in security with Sysdig and Falco. So before I start, I know I'm competing against Holiday and against free beer and pizza. So let's do it together. So who likes Kubernetes here? Just one hand. I want more. I think like put your feet. So yeah, starting to talk about the Falco. I think it's important, as if you were in the KubeCon or you heard the keynotes. I think the community is like, we don't know which level you are. I don't know if you're a specialist in Kubernetes or you're just the first time you're here in the conference. So I think like bring an idea of what we want to talk and then go deeper. So understanding runtime security is like you need to understand the behavior from a source, from a trusted source. Like we need to monitor your system to understand the behavior at runtime. It can be a little confusing if you think like of this definition, but you certainly hear if like I heard from the poll that or some DevOps, SRE, etc. You probably use or have heard about Wireshark, right? Yes, no. So Wireshark, what it does is we run a TCP dump, we collect data, we collect raw data, but data are supposed to be for systems, like they are software information, and we are humans. We need to confirm this information. So what we do with Wireshark is we collect the TCP dump. So there's a lot of things with JSON, etc., like very scientific rocket stuff, and we convert to check what we're looking. So similar, what we're doing in security is we're going to change the behavior of like a network card. So if you check a network card, it doesn't give you the context. We need to get the TCP dump to understand what's happening. The same happens for security, but then we're talking about system calls. And as we're looking again to do comparison for the network card here, the kernel will be the source of truth. So I need to understand what's happening, what's touching my kernel to know what's this security on runtime. And why? So then we need security on runtime. We, as you mentioned about Kubernetes, containers by definition should be immutable, right? They're supposed to do only what the entry point is asking them to do, but we know this is not the reality. You can enter in a container, you can install package, and this brings some problems or drawbacks of using container technology. First, things can drift from the image. So we have a CICD vulnerability management, we perform a scan, but this is a point in time. It's like a photo. Like I took this, I know what's happened, but things can change. Maybe it's only present to runtime. So I do the CICD, I did my test, but I was not able to capture what's like a problem. Only is present when it's running. And of course, when you talk about 0 days, or unknown threat, so how can you scan something that you didn't even know yet? When you go to like instance response, so we lost, when you have again containers, we lost a little bit of the ability to know what happens inside, and the forensic. So if something happened, what happened, or how can I prove that no one touches that or did something? if you work or have a company that like PCI needs SOC 2, all of these fancy standard names that we talked about the policy before, you know that you need to follow some policy, to follow some rules to compliance. If maybe it's still a little bit blur, why you need runtime security, maybe this image makes clear for everyone. So we are almost the whole world, as you showed in the whole presentation, running Java or trust Java applications for a long time without seeing that log stuff was there, just making logging, were able to cause as the problem we see. So this is why runtime security is important. We need to be aware of what happened, be prepared for something we still don't know what is it. And then we come to Falco. So Falco is a project, the Falco project, it's a runtime security designed by Sysdig, the company that I work, and is donated to CNCF under incubated project. So what Falco does is parsing Linux system calls from kernel to runtime, parsing Kubernetes audit logs, and asserting a stream against a powerful rule engine. And more than that, alerting when a rule is violated. So it's very important that if you note something's happened at a cloud level, or like we're talking about cloud native stuff, we cannot rely on like take a snapshot or just forward everything for CM and then run something 2-3 days later to see what's going on. We need something more like real time. One thing I want to mention about Falco, if you have heard about Falco before, a new thing is called Falco plugins, which extends Falco to new abilities. The most two like GA, let's say, or more famous plugins now, it's AWS CloudTrail and also Okta logins. So probably you have heard about the Okta problem that was there in the news. So we are able to use Falco to use the same idea of like parsing the Okta logs to see what's happening. A little bit like technical, and here is the models here. Yes, okay. Oops. Sorry. So the thing is how Falco really works. So using eBPF, we go to look in the kernel. So yeah, this seems to be very technical, but imagine like a security camera. So we are watching what's happening in the kernel. So if I have an application running on Linux, for example, Nginx, and then Nginx says, well, I need to read my Nginx config. So I need to read something from a file for a disk, or maybe I need to open a port. So hey, kernel, please open a TCP socket for me on port 80, because I'm gonna need to use this in my process. The same happened when we are using a container. So we are getting the same process, the same application. We're just like containerize them. But at the end, we're also assessing the kernel in the same way as directly from the application running the kernel. So what we know what's happening inside the container, actually, we just need to know what's happening the kernel side. So containers are the sub-process of a kernel. So we have the runc, Docker, CRI-O, Rocket. We have so many projects nowadays. We just need to know what's happened up after this process, and we know what's happened at the container level or the operational system. So we feed Falco with rules that, of course, written YAML, because every DevOps or SRE loves YAML. And then we have the outputs that can be directly to file or text or even different output source. And then again, as I mentioned about the runtime, is we need to use a source of truth. In this case, we're really trust on kernel because kernel never lies. How is the rule? So the Falco rules, like as I mentioned before, they are YAML. So we have like the role name, the description, because yes, we are humans, so we need something to remind us what this is doing. Then comes the condition, which is like the real magic. When this conditions trigger, I go then send an output, which means if something is executable inside my container and the container ID is not a host, which means I'm create like a filter here and I'm looking for a process like bash, then I want this rule to be triggered. In the above part, we see what is the result. So how Falco reacts if this happens in your kernel. So the main magic here is you see that in the output of the rule, that's user equal percentage user.name. And then Falco gives you that root, the user was root. Imagine that we're checking millions of system calls, so a lot of things happen in your environment, and then you need to find who is the owner of that process. So you need to, like, let's say, create a lot of greps, a lot of findings. What this the magic of Falco is very similar to Wireshark, is get that information, like the raw data that the system produces, and bring this as a human way to read. So this is the user, this is the container ID, the container name. So get all this process together and bring the information. One thing that I heard a lot is, well, it's nice, but I don't know how to write rules, or what should I start? So the nice thing about Falco is we have a lot of out-of-the-box rules. So kind of 67, 69 rules now, as per checking the GitHub yesterday. So this can help you, like, to start to protect your system. This is one of the most used one, as if someone open a shell in a container, and this container is like running production code, probably some attack or something weird behavior. Moving to then the commercial platform about Sysdig. So Sysdig has this, what we call Sysdig secure platform, that as was mentioned before, the idea is like shifting left as much as possible, starting from the code. So evaluate Terraform infrastructure as a code like Helm, this kind of stuff. Going to the build phase, so scanning, CI/CD, all the vulnerability management. When you go to run, enforcing policies. But here, especially as we're talking about runtime, I'm going to focus on threat detection, which is what we mentioned about what Falco can do, and instance response. One important thing is the whole platform of Sysdig, and also why Falco is so important, as I mentioned before, is the compliance. So again, doing as we saw in the first talk, the policy. So implement some kind of policy. How do we implement a policy? How do we bring these policies to a workload? This is how the platform is designed. So how Sysdig extends Falco? As I mentioned, Falco is the open source solution that we donate to CNCF, but inside what we call the Sysdig agent has the technology of Falco baked in. So the system calls, similar to what we saw before, Kubernetes audit logs parsing. So if you anyone use like AKS, GKE, or EKS here, or managed Kubernetes. So if you use managed Kubernetes, you may be aware that you lost some ability to the ControlPlane. Like you believe or you give your cloud provider to take care of you. So this also has a drawback because you lost the audit of Kube API. And then of course you can stream to CloudWatch, but you need to then create queries to know what you're looking for instead of be aware what's happens inside your Kubernetes. So Sysdig has a demission controller that uses the Falco technology inside the cluster. So everything that goes to API server, we are able to identify the API and then create rules to match and alerts. And the third thing is the cloud logs activity. So in here, again, we need the source of truth. We are changing the source of truth from kernel or from Kubernetes audit logs for the cloud. So like CloudTrail, GCP logs, Azure, etc. The main idea here is use a common policy. Is they use a common policy similar as we used for the Falco they showed before. We are able to use for, like, say, parsing the AWS CloudTrail, or even parsing like a Kubernetes API. As we know, there's a lot of tools outside. So how you concentrate out of the tools, or even like the teams, that it's not easy to find DevOps people. I think everyone knows, even DevSecOps, even harder. So as much the complexity you insert of different rules, even harder. So if you use a tool based on open source standards, something you can like find blogs or articles or even speaking like this one, it's way easier for your team to ramp up. So this is how the platform is built. And one big challenge when we talk about cloud native is it's nice when you start with one region and one cloud account, then you go to multi-region, and then you go to multi-cloud, multi-account, and then you go to what everyone says like multi-clouding, or how do you have everything together? How do you see what's happened? So the platform has the idea of unified view. So it doesn't matter if you're running one of the three cloud providers, we're able to concentrate the output for the cloud providers in the same view, and then using like this bubble chart to give you an idea of what's happened. The important thing here is history. So if you're looking, who here have problem to look in something on CloudTrail, like after 90 days, you need to create Athena queries, go to S3, is a lot of challenge. So the main idea of the platform, as I mentioned about compliance and audit, is keep a history. So we keep like 50 months, so you can easily go back on time to know what's happened, and then compare like, well, this happened on my cloud account, it's also happened on my workload level, and easy get a conclusion. And as every open source project that has a commercial tool, well, what's the main difference between using only Falco or using the Sysdig secure? So Falco, it's based on parsing audit logs or syscalls, and as I mentioned, the plugins, and only provides alerts. While Sysdig secure, not only we can alert, we can also perform remediations. So go one step ahead. Out of the box policy for like meter detection, compliance, file identity manager, like this kind of security that your company may need to face. Kubernetes segmentations, I think someone asked about network policy before. Something we see, like if you're going to apply network policy, it's very common that people are like afraid that implement network policy, and everyone knows what happens if you deny core DNS inside the cluster. Everything goes down. And then also, as I mentioned, the ability to then get Kubernetes audit logs from like EKS, GKE, AKS, or every Kubernetes managed provider solution. When we have the main difference to apply a rule when you use Sysdig is what we call policies. So the policy has the ability to run as a scope. For example, I want to apply a rule that only gonna be matched if the namespace is like terminal sharing container or the Kubernetes cluster is like my cluster. The main thing about this is we can have actions. So if someone open a terminal shell or someone do an outbound connection or read a file that shouldn't, and my namespace, like let's say production, I want to kill the container. So I want to go one step ahead instead of just be alerted. I want to reactive. I want to know what I want to block the bleeding of my container, and I want to forward these events. So like forward to Slack, PagerDuty, etc. And especially the idea to create a capture. So it's not even similar because the same creator. So the creator of Wireshark is the founder of Sysdig. So he brought the same idea is, well, I want to know, for instance, what happened inside my container. So a terminal shell rule was being triggered, and I want to see like the capture with inspect, which is another open source tool from Sysdig called Sysdig. So what I can see here is inside the container, what happened. So general files, networking, network apps, security, performance. So I'm able to see, reconstruct what happened inside the container, but especially if I go and check executed commands, I'm able to reconstruct what happened at the terminal level inside the container. So for example, here, the attacker opened the bash. This was the rule was triggered. It downloads something from GitHub. They code base64. Even at the end, try to delete the bash history, which is, we all know that it's mainly the common way of attacker. We are able to detect. Again, how we can do this? Because we're checking directly on the ring buffer on the kernel. So it doesn't matter what happened inside the container. If the container dies, someone killed the process 0, process 1 of the container, we're still able to collect. One thing that I really suggest to use is every year Sysdig release a report about cloud native and security usage that we collect some data from our customers. The main thing is we don't interview customers, because if you interview someone, say, hey, how much you are secure? No one's gonna say, well, we have a lot of flaws, we have a lot of problems. So it's not a question. It's like data that we gather from our platform. So I want to just highlight the container runtime alerts that we must see is terminal sharing container, the second container launch with sensitive mode points, and the third launch privileged container. So all of the things that we know when talk about security can result in escalation. So go from the container to the host, and then from the host, maybe even for a cloud account. And one more nice statistic is where the image is scanning. So at CI/CD pipeline, 42% at the runtime, which means they were not scanned on CI/CD. It's only being scanned when they're already running, so they're already being deployed. And 6% of registry, which is good because scan registry is, again, we are doing only a snapshot check, so it's not the best solution. Yet 76% of containers run as a root. You may be aware that there's a way to not run as a root when you create your Docker file. And this is very important, like to spread like to developers, is it's not so hard to just add some lines of user and then test. And this helps to a lot in how we can avoid breaks or problems in your infrastructure. the last thing, almost the last thing. So if you want to start to test Sysdig, it's for free. So just go to sysdig.com/start for free. There's no credit card, no need to register. Also, if you want to know a little bit about Falco, go to falco.org. It's also, we have the Slack channel and the Kubernetes community. And the most important thing is, if you want to get a t-shirt cracking like mine here, you can go to this website, get.rich-com/swag-bundle-nemia. So yeah, it's the marketing thing, you know. But yeah, we're gonna deliver then a t-shirt to your house. Thank you. Any questions?
Mention the book. You should mention the book.
Yeah, good catch for the next one.
I don't have the reasons. One, the newest one is the UPF, but you had a current module and also user specification. You drop those?
No, we mostly use more kernel module than eBPF. Mostly like kernel module is still more efficient than eBPF. But for some cases like GP calls or node operational system that does not support kernel module, that's why I use eBPF.
So do you support Fargate and Fargate with EKS, for example, where you don't have access to the kernel, run eBPF?
We support Fargate on ECS, not on EKS, because to supporting runtime, you need to like or have access to kernel, or you need to like somehow expose the way to get the tracing from the systems. On ECS, Fargate 1.4, they expose the bit tracing, so we're able to collect. On EKS, they still use 1.3, so it's not possible.
Also, a follow-up question. How would you compare Falco to Tetragon? Because Tetragon seems like it's doing similar things.
Honestly, I know a little bit about Tetragon, so I cannot like give you, I just know there's a Cilium product, but I know there's now open source, but I don't have like deep integration to give you.
And you haven't participated in Micro in any of the competitions, right?
Sorry?
Have you participated in Micro competitions in the last years with the agent you have?
I don't know how to say this, like.
No, Micro does an evaluation of endpoint security products every year, and I wondered if you participated or not.
I need to check, honestly, I don't know.
Okay.
Cool.
All right.
Okay, that is the end of our meetup tonight. Thank you so much everyone for coming.
We'll be back again on the first Wednesday of July. We'll be back here, first Wednesday of every month. Someone from esynergy can now tell us the best hub to go to around here.
Any offers?
Available. What's the best hub
around here?
Lame.
Okay, we will figure out a pub to go to after this. If you want to come and hang out for a bit longer. Otherwise, thank you so much. Yeah, so online, if you'd like to come in just for the pub, you're welcome to come to the pub. Thank you so much. Have a good day.
Take a picture.
Are you heading? One, no, I'm gonna come for one break. Yay! But just one. Just one.
No, I also have plans.
I tried, I guess.
No, you did. You did.
I was just lying alone at home. I feel bad.